Person, when you hear about artificial intelligence beating world champions, solving protein structures, or playing complex video games better than any human, there's a high chance DeepMind is behind it. DeepMind is one of the most influential AI labs on the planet. It's where some of the most groundbreaking advancements in machine learning have emerged, changing not only how we think about AI, but also how it can be used in science, healthcare, and everyday life. So what exactly is DeepMind, and why does it matter? Let's start at the beginning. DeepMind was founded in 2010 in London by three ambitious minds: Demis Hassabis, Shane Legg, and Mustafa Suleyman. Their goal wasn't modest. They wanted to create artificial general intelligence, AGI. That means AI that can think and learn across tasks like a human. Demis Hassabis, a child chess prodigy, neuroscientist, and game developer, brought a unique blend of science, strategy, and creativity. He believed that by understanding how the human brain works, we could build machines that learn in a similar way. Early on, DeepMind didn't chase commercial products. Instead, it focused on building fundamental AI capabilities, starting with deep reinforcement learning. That's a method where AI agents learn by trial and error, getting better over time, like how humans learn to ride a bike or play a game. In 2014, Google acquired DeepMind for around $500 million. It was a bold move. The company had yet to launch a product. But Google saw its potential, and DeepMind became part of Google's parent company, Alphabet. Just a year later, DeepMind changed the game. In 2015, it introduced AlphaGo, an AI program that could play the ancient board game Go, considered far more complex than chess. In 2016, AlphaGo defeated Lee Sedol, one of the world's best Go players, in a 5-game match. The victory stunned the world. It wasn't just a win for AI, it was a wake-up call for what machine learning could do. What made AlphaGo special wasn't brute force. It used a combination of neural networks and a method called Monte Carlo tree search to predict and evaluate moves. It learned not only from human games, but by playing millions of matches against itself. DeepMind didn't stop there. They developed AlphaZero, a generalized version that could learn to play Go, chess, and shogi, all without human data. It mastered each game by playing against itself and surpassing the best AI systems within days. AlphaZero showed that machines could discover entirely new strategies, ones that even top human players hadn't thought of. But DeepMind's ambition wasn't limited to games. In 2020, it made headlines again with AlphaFold, an AI system that solved one of biology's grand challenges: protein folding. Proteins are the building blocks of life, and their 3D structures determine how they function. Predicting these structures from amino acid sequences had stumped scientists for decades. AlphaFold cracked the problem with astonishing accuracy. The implications? Massive. From drug discovery to understanding diseases at a molecular level, AlphaFold opened doors to medical and biological research that once seemed years away. DeepMind made AlphaFold's results open to the world. It released a database of over 200 million protein structures, essentially covering nearly all known proteins. This act of scientific generosity accelerated research across fields and cemented DeepMind's reputation not just as a tech innovator, but as a force for public good. So how does DeepMind build such systems? Their core approach combines several AI disciplines: deep learning, reinforcement learning, neuroscience, and symbolic reasoning. They don't just train bigger models, they build smarter architectures. DeepMind has pioneered memory-augmented networks, meta-learning, and energy-efficient AI systems. One notable feature of DeepMind is its focus on scientific discovery. Rather than chase products, they use AI to push human knowledge. They've built AI that navigates, reasons, and proves theorems. In 2022, DeepMind created an AI that solved previously unsolved combinatorial math problems in collaboration with mathematicians, a first of its kind. And yet, for all its brilliance, DeepMind has critics. Some argue that being part of Google raises ethical concerns. Who controls these discoveries? How are they used? In its early years, DeepMind had an independent ethics board, but reports suggest it lost much of its autonomy as it was folded deeper into Google's corporate structure. Still, DeepMind maintains a strong internal emphasis on AI safety and harsh alignment. It has dedicated teams working on making AI transparent, fair, and controllable. Its researchers publish frequently on explainability, robustness, and long-term risk. In 2023, DeepMind merged with Google Brain, another top-tier AI research group, to form Google DeepMind. This consolidation brought together some of the brightest minds in AI under one banner, accelerating research on large language models, robotics, and multimodal systems. Today, DeepMind works on everything from robotics and language to health and climate modeling. Its Gemini project, rumored to be Google's next major LLM, aims to rival or surpass systems like GPT-4. Unlike many labs, DeepMind emphasizes reasoning and planning, not just pattern recognition, in its next generation of models. So what makes DeepMind different? It's not just what they build, it's why they build it. From math to biology, go to ethics. DeepMind aims to solve intelligence and use it to solve everything else. It's a lofty, maybe impossible goal, but each breakthrough gets them closer. DeepMind isn't just explaining AI. It's helping redefine what intelligence, human or artificial, really means. Let's zoom in on some of the lesser-known, yet equally fascinating areas DeepMind is exploring. One of them is AI for mathematics. In collaboration with mathematicians from Oxford and Cambridge, DeepMind's AI helped identify patterns in knot theory and representation theory, two abstract branches of pure mathematics. It's not just solving equations. It helps humans ask better questions and find new ideas. Another area is AI in healthcare. Long before AlphaFold, DeepMind partnered with the UK's National Health Service to develop systems that could detect eye disease from retinal scans and predict acute kidney injury 48 hours in advance. While some of these projects raised privacy debates, they also showed how AI could be used to detect, prevent, and manage illness in real time. The company also focuses on energy efficiency. It developed AI systems that reduce the energy used to cool Google's data centers by up to 40%. That's not just saving money. It's reducing carbon emissions and environmental impact. It's a real-world application of AI to fight climate change. DeepMind's research on multi-agent systems, where multiple AI entities interact in environments, could have huge implications. From autonomous vehicles navigating cities to financial agents interacting in markets, understanding how AI systems behave in groups is essential for the future of complex AI-powered societies. And let's not forget DeepMind's influence on AI, education, and ethics. Many of its papers become standard reading for AI students. Its team regularly engages with the academic community, open sources tools, and contributes to global discussions on AI policy, governance, and responsibility. But perhaps the most interesting thing about DeepMind is its culture. Unlike many labs driven by rapid product cycles, DeepMind fosters long-term thinking. It hires physicists, biologists, and philosophers, not just coders. It treats intelligence as a mystery, not just an engineering problem. And it views each scientific breakthrough not as an endpoint, but as a stepping stone toward deeper understanding. That mindset may be DeepMind's biggest innovation. In a world racing to build faster models and capture market share, DeepMind reminds us that AI is not just about speed. It's about purpose. It's not just about what machines can do, but what they should do and why. As AI becomes more powerful, the questions DeepMind is asking about alignment, generalization, creativity, and safety will shape how technology evolves in the next decade. And while DeepMind may not have the brand visibility of Apple or the cultural presence of OpenAI, within the scientific and AI communities, its influence is monumental. So next time you see a breakthrough headline about AI folding proteins, discovering new strategies in Go, or solving math, look a little closer. DeepMind probably helped make it happen. DeepMind is redefining what AI is and what it might become. As we look to the future, DeepMind's vision continues to evolve. The company is actively researching artificial general intelligence, not as science fiction, but as a serious scientific goal. It's refining architectures that can learn faster, transfer knowledge between domains, and reason with abstract information. It's also testing AI that writes code, moves through space, and collaborates with humans. DeepMind's questions now go beyond performance into ethics and cooperation. Can AI be taught to debate, to explain its reasoning, to defer to human preferences when outcomes conflict? These are no longer hypothetical challenges. They're design decisions happening in real time. That's why DeepMind matters. It's not just inventing tools, it's thinking how to use them. In an algorithm-driven world, we need builders with vision and purpose beyond profit. DeepMind is trying to be that kind of institution. And in doing so, it reminds us that intelligence, artificial or otherwise, isn't just about solving problems. It's about understanding the world more deeply and choosing to use it well.